Homework. Page 336. What do we got? What kind of questions? What do you got? Number 12. Okay. So we got x to the root 32, y to the negative root 200, raised to the root 8. All right. First thing with these, you got to figure out, should you add, subtract, multiply, or divide? Powers raised to powers, what are we going to do with these numbers up here? We're going to multiply. So I have to basically multiply the square root of 32 times the square root of 8. Well, my exponent rule or my rule means I can multiply those two numbers together. You could multiply them together if you want. I like to just write them like that next to each other and just start breaking them down right now. What's 32 break down into? 4 and 8. So hey, I have a pair of 8s already. Don't have to go any farther there. That breaks down to 2 and 2. So I have a pair of 2s. I got a pair of 8s. That breaks down to 16, and there's no leftovers, right? So when I do power to power, that gives me x to the 16th. What about the y's? So the y's, get that out of here, give me some room. I have to basically do the same thing to the square root of, or negative square root of 200 times square root of 8. Break that down, 208, that's 102, that's 10 and 10, 2, 4, 2, 2. So you got a pair of 2s, you got a pair of 2s, and you got a pair of 10s. So that's going to be 40. Negative times the positive is negative 40. So I got y to the negative 40th. What's the only thing I got to do now? Put that negative exponent on the bottom. So my final answer is x to the 16th over y to the 40th. When we go through homework, I am going to ask you one crucial favor. If you get a question wrong, what do you think is the very first thing I want you doing? If you got that question wrong, you did not have it perfectly correct. What is the first thing I want you to do? It's not fix it. It's not. I want you to fix it, but it's not the first thing I want you to do.
Figure out what you did wrong.
Where did you go wrong? That's why showing your work is so important. Kids always think teachers want you to show your work, especially math teachers want you to show your work because they don't want you to cheat. It has nothing to do with cheating. You could cheat and show your work. It's just more writing. Why show your work? Why is that such an important thing? We all make mistakes. You got to show your work so that you can find your mistakes. If you just say the answer is 40, how'd you get that 40? I don't remember. You have to be able to walk that problem back through and go, all right, I did step 1 right, I did step 2 right, but step 3, oh, I went 3 plus 3 is 9. Silly me. That's where I went wrong. Or I broke a math rule or whatever that error is, and then you can fix that mistake. You have to identify your mistake. And sometimes that's a hard thing to do. If you follow your own logic, it made sense to you when you did it the first time. That's why you wrote it down. If it made sense to you the first time and you follow your own logic, a lot of times it's going to make sense the second time too. Sometimes it takes a fresh set of eyes. Hey, will you look at this for me? If you can't figure out where you went wrong, call me over. Ask a neighbor, hey, where did I go wrong here? How did I get this answer? Once you figure out your mistake, what's step 2? Fix it. Now do it right, okay? So please identify those mistakes if you didn't get that right. All right, how'd you guys do with the calculator stuff? Okay. Real quick, I'm just going to read those answers. 14 is 2.445. 16 is 2.56. 18 is 0.409. 20 is 0.39. 22 is 78.386. And 24 is 2,550.3. Yes?
How do you do the ones where the exponents are radicals plus other radicals?
So like 22?
Yeah, like 22.
So it's going to vary. It really is going to vary by what type of calculator is sitting in front of you. Okay? And some calculators are really easy to do this problem. Some are really hard. Like this kind of calculator makes that fairly simple because this has that math print software, and basically the only thing you have to do is make this look like that.
Yeah.
So you press the 4. Now I want to go in the exponent, and I can see I'm in the exponent because it's superscripted. It makes it small. It makes it go, moves it up. I press the square root button. I press the 3, but now I want to end the radical, right? So I got to press over. Plus, but I'm still in that exponent. I know I'm still in the exponent because I can see that. And I just type that in. Now, while this type of calculator is fairly simple, I don't see any scientific calculators around. That one would be really tricky to use. Now, it's doable. It's just, you have I press the same buttons and it goes 4 raised 2, and I do the square root, and then maybe it opens a set of parentheses and I press the 3 plus, you have something like this is what your calculator kind of looks like. There's a lot missing there. When I press the over button, the right button, that closed that square root. Well, what do I need to make sure I put in here? I got to put a closed parenthesis to close that square root. Otherwise, this is going to have that square root keep going. But even if I have this, is this going to calculate the same thing that is? No. What is this actually going to calculate? This is going to do 4 raised to the square root of 3 power, get that answer, and then add the square root of 2 next to it. That's not what we want, right? So it's not going to give us the correct answer because we didn't type it in. What's the one thing that this is doing wrong? What do I need to add to this to make sure it's going to go right? Where? Yeah, I need parentheses around everything that I want in the exponent. So I need this all to be in parentheses. So using a calculator that doesn't have the math print, you just simply have to be very, very careful with your parentheses kind of thing. And yeah, a little scientific one like that, that's going to be tricky to use. So if you have a calculator that's tricky to use, what are your options?
Upgrade.
Can upgrade. What's option 2? Get familiar with it. Because it's your calculator, so get familiar and learn how to use it. I mean, I have a chainsaw at home that I don't ever loan out to anybody because it's a pain in the butt. It's tricky to start. You got to pump, you got to have, you got to prime it really well. The choke, you got to kind of put it like, not at full choke, but slightly above, and I've learned how to use this thing, right? I've learned what it can do, what it can't do, because it's mine, and I've used it 100 times. Why don't I loan it out to somebody else? Well, yeah, they could hurt themselves, but also they'll never get the stupid thing started because they can't figure out the choke trick. There's tricks to certain tools that you have to get familiar with, right? So, same idea. It's your calculator. You need to get used to it because that might be the one that you're actually going to use in a pressure situation. And you still got to be able to get the job done. Are we good with those? All right, something we didn't really talk about yesterday was 26. 5 to the 4th, 25 2x. What's the goal of this question? solve x. What makes this problem look hard? What's different about this? You've solved hundreds and thousands of problems already where you had to solve for x. What makes this one different? Where is the x? It's in the exponent. Holy cow, we don't have anything in our toolbox right now that can get an x out of an exponent. So we're going to have some different tricks. This is actually what a lot of this chapter boils down to, is these types of questions. And some of them are a lot easier than others. One trick to doing these. You guys know the Indiana Jones movie? The first one, the main one, right? He goes through all the crazy obstacles, almost dies a couple times, and he finds that golden monkey, right? How does he actually pick up the golden monkey? Huh? Trades it. He swapped, right? He puts something there, a bag of sand that is exactly the same weight, or at least what he thought, right? He kind of screwed it up, and that's why the giant boulder came chasing him down the hall. But anyway, so he's got that golden monkey he wants. He's got to replace it with something that's equal to that, right? We're going to do the same thing. There's part of this problem that we like, part of it we don't like. We got to replace that with something else that's equal to that. Solving this problem is not, you have to get out of the train of thought of solving problems like 4x plus 8 is equal to 12. How would you solve this problem? You're going to minus 8. You're actually going to minus 8 from both sides, right? Because those are some basic algebra rules. We are not using those kinds of tricks, okay? What we're doing here is we're just going to replace parts. We're going to basically take that golden monkey and go something else that's equal. This 5, I'm going to leave that alone. That 25, I don't like that 25. I'm going to replace it with something else that I know is equal to 25. I could use 26 minus 1. Would that be okay? Is that legally allowed? Is that the same thing? Yes. Is that the bell already? Oh my gosh. I gotta stop talking.